In this video, we are going to continue our discussion of 11.6 with graphing. We are going to move on from cylinders to something called surfaces. So this is my introduction. I will go through shape by shape, or surface by surface, rather, is probably how we should say that. So how you can tell if something is a surface. 3 variables. So a cylinder, remember, was 2 variables. Surfaces have 3. Traces that occur on coordinate planes or on planes parallel to coordinate planes. So the traces will be almost like a contour map. I don't know if you guys remember, like if I have this map, let me draw. You guys have seen this before at some point in maybe public education, but they would like, okay, a mountain, they may do this shape and then this shape and then this shape. And it was like telling you how tall the mountain was, a contour map. We are going to look for traces like this. So it's going to be like, this could be looking down on the XY plane where Z is coming out at us. We can see the different types, and then we'll be able to do traces in other directions as well to kind of get a full 3-dimensional picture. Still directed along an axis, but the trace changes along the axis. Like in a cylinder, let me scroll back up real quick because I have my shapes here. But this shape was the same as it came across the x-axis, while a surface is going to change as it goes across the x. So here are the steps to graph. Determine the type of surface. And I'll give you directions on how to do that. Determine direction axis, and then find trace on coordinate plane. And then we have to find at least 2 other traces along direction axis. This doesn't make much sense right now until we get into it. So let's do this. So the first surface we are going to look at is called an ellipsoid. As you can tell, it looks very much like if we covered this up, we have an ellipse in 2 dimensions. So ellipsoid adds the 3rd dimension. These look a lot, I think, like a bean is how I think about it, but we'll see. So how to tell? I'm going to give you some steps to decide this because we're going to have other ones that look super similar to this. So the first thing is going to be that all signs are positive. Or there's a way to make them all positive. If you can make them all positive, then this is it. The next one, all have a power of 2, except for the 1. The 1's always 1. And then 3 has a constant term. And what I mean by constant term, I mean the 1. Not A, B, and C are going to be constants, but they're put together with the X, Y's, and Z's. Okay, I'm going to give you some notes. We're going to go through this where I give you the name, give you the equation, how to tell, some notes, and then we're going to graph one. All right, so notes. Standard form helps with traces. So if you will put it in standard form, it will help you with traces. All right, the intercepts for this, where it crosses each axis, x is plus or minus a, y is plus or minus b, and z is plus or minus c. So it'll cross each one of those axes at each one of those points. All right, we're going to do an example so you guys can take a look, can see how what an ellipsoid looks like. All right, so here's our example. 9x squared plus 4y squared plus z squared equals 36. So the first thing I want to do is I want to identify the type. All right, well, I see that they are all positive. Right, all positive. I see that they all have squares, except for the 36, but we don't care about that. We care about the variables. Squares. And then there is one constant term. So this is 3 dots forward. Therefore, it's an ellipsoid. Let me try to spell this thing right. Okay. It is an ellipsoid. All right, the intercepts. Well, first thing, the note said, put it in standard form. So I'm going to take that equation up there and I'm going to divide everything by 36. So I get x squared over 4 plus y squared over 9 plus z squared over 36. Now that's in standard form, and I know my intercepts are x is plus or minus a. Well, 4 is a squared, so it's plus or minus 2. Y is plus or minus 3. And z is plus or minus 6. All right, so this gives me all the information I need. I know that the intercepts are 2 on the x-axis, 2 and negative 2. There are 3 and negative 3 on the y-axis, and 6 and negative 6 on my z-axis. So what this looks like is the trace here. You guys could let z equals 0, and you would find that you'd get an ellipse with 2 and 3. If you take a look at your equation, right? Oh, this should be equals 1. Sorry about that. But if you take this and you let x equals 0, or let's do this one, the one we're on, z equals 0, we get x squared over 4 plus y squared over 9 equals 1. And that's an ellipse. And it has a is 2, b is 3. And that's why right there that we drew down here in the red ellipse there, that's why we have in the x direction we have 2, in the y direction we have 3. All right, now if we were to think about letting y equal 0, we would have x squared over 4 plus z squared over 36 equals 1. And you could see what you need here. This is x and z. Okay, so x and z. I know that x has 2 again, that's good, but z has 6 and 6. So we actually have an ellipse like this. Hold on, I have a dotted line. Cool, and you could even do this side. Technically, we can't see that either. Okay, that covers 2 of those. Now we could do one more trace here. I could say let z equal 0. Oh, we did z equal 0. X equals 0. If I let x equal 0, I get y squared over 9 plus z squared over 36 equals 1. All right, that is an ellipse in the y direction and z direction. That's flat. Y has 3, z has 6, so that is right here. And technically, all the way like that, we'll do this. All right, and there's my ellipsoid. You can see it. This one actually is pretty good. It's probably the best one I've ever drawn, even though it has some of these crinkles here. It's still decent for me. So I'm going to show you a picture of this so you can see what it actually looks like. We don't actually have to go through all of this every time. Notice every point that was on there was already there based on this. I could just plot those 3, plus or minus them, and draw the shape, right? Okay, let's take a look at the actual graph. Oh, it's not that shape. It's going to be this one. So we get stop spinning. Kind of hard to see the dimension. There you go. They do it pretty well there. So it's that bean type shape. Our picture is like this, I believe. I can't remember what my... Oh, wait, no. I think it was like this. That's what it should be. So there we go. You can see the pictures look... You can't even tell a difference, right? No, mine's not great. So there it is. That is an ellipsoid.